How's it going, y'all? Sorry for the late start. Just want to check, can y'all hear me? Good morning. Yeah, so it's been a hectic morning so far. I had to prepare everything for the stream today and a lot of stuff with school, so I had to start 10 minutes late, but awesome. Out of curiosity, who here was here yesterday? And for those that were here, anything that you liked or took away from yesterday's workshop? If so, feel free to leave it down below. Hey, thanks for being here yesterday, Pharaoh. Appreciate it. And Green Yoshi. Did y'all like the format of it being coded together? Just to check for future use cases. Thank you now for the Twitch logo. Sorry, my MacBook is acting a little funky right now. Yeah, VS Code is awesome. I love how it has so many collaboration tools. A really cool thing is if y'all have heard of Zed, which I think I pitched yesterday or during the previous workshop, it also provides a lot of cool collaboration features, but unfortunately it's still a new product and hasn't been adopted as widely. So maybe whenever it gets more adopted, we can switch to that. Thank you, Farah. Is it Pharaoh? Oh, I just there's the 404 in it. Wait, isn't there's someone else also named 404? I think he said something in chat earlier. There are two 404s. That's awesome. Add 404 not found. 404 not found. Are you in chat today? Hey, how's it going? I hope this isn't too late right now. It is 10:40 p.m., which is a little bit late, but not as late as 3 p.m. yesterday, which I'm happy we can get an earlier time slot. All right, just give me like 10 more seconds trying to get my screen sharing to work, but that it's almost ready. He's speaking Korean or Arabic today? Me? You're actually scarily close to what my ethnicities are, so I'm a little bit shooken. All right. I am now putting up the slides, and let's begin part 3 of the stream today. Excited for everything that we're doing. All right, and let me know if y'all can see my slides right now. Oh, LOL, for real. Hola. All right. So as mentioned earlier, let me actually change the music so we don't get bored of this one. Let's do a nighttime driving tune. Okay, I hope this makes you all sleepy. All right, actually, let's do something more upbeat. I'm kidding. This is interesting music. Yeah, Farah. I'm a half Moroccan, half Viet. So that's interesting. And I guess this is the introduction slide. How convenient. So I'm Ryan, a coach at Major League Hacking. I am a lettuce enjoyer. So feel free to put some lettuces in chat or in the MLH Discord. I am the third Ryan from MLH. This music is so loud. All right, I'm the third Ryan from MLH, and I am part of the blue team. If you want to add me, feel free to add me on LinkedIn or on Insta. At LRyanLE on both of them. But without further ado, we are working on securing and authenticating APIs today, which is part 3 of this 3-part workshop series, which is honestly a lot. So we're going to be working on what we've been working on previously, which includes, sorry, actually, before we get there, no, I'm going to complete that, yeah, which includes working on our project, which is awesome. So as far as session roadmaps go, this is our third and last session today at 1 p.m. Eastern Time. Thank you all to everyone who has joined me in the past 2 sessions. But as far as what we're working on today, segment 1, or the first part of the stream, is going to be focused purely on security overview, authentication overview, and encryption and securing data handling. So basically just talking about data security and information security and working out and trying to learn how all of these work. And then in part 2, we're actually going to be coding again with Hackpack Code with Ryan, and we're going to be implementing token-based authentication using JSON web tokens into our project. And then if time permits, we'll also try to implement we'll talk about OAuth 2 and work with API gateways and rate limiting. So yeah. Okay. So unfortunately, no worries. We'll talk to, there's actually on the MLH Discord, and I think is it Hack Together, the channel. Let me check real quick. Yeah, in the Hack Together channel, part 1 of the slides were uploaded there. Part 2 is mainly working together on a project, which just includes scaffolding a Express.js project with SQLite. And this is basically to be implementing user authentication, so being able to log in, sign in as a user, and access our resources. So, yeah. No worries if you haven't had the chance to. In the end, this session is going to be pretty independent from the others, and in fact, it's assuming no prior knowledge as the previous 2 were. So if you weren't able to catch it, that's a-okay. You're still good to go. So so the first half is going to be mostly PowerPoint presentations, but I'll try to make it as interactive and as not boring as possible. And if you can pay attention probably to the second half of the entire presentation, you're going to get a lot of useful information from that. So I would definitely recommend staying for that part. And I'm going to change the music again because this music is so weird. Let's see if this works. Okay, let's go back to the original. All right, is this good? All right, I like this music. Okay, so fun fact, I'll try to throw out some fun information here and there just to get your attention here. So fun fact, an average organization today has around 16,000 plus APIs. If you think about that, that's a lot of APIs. I don't know if that's able to I can't speak today. Oh my gosh, yeah. It's just a lot of APIs to have and a lot of application and products that are using these APIs. And then for an average enterprise, so large scale company, let me lower the music. They normally have 26,000 plus APIs. So in the end, you have a lot of application programming interfaces all interacting with each other, which is a lot of data. And if you think about it, imagine you had 16,000 pennies and you had to keep track and know where every single penny went. Imagine how much of a nightmare that would be, especially if you had a team of, let's say, 20 people working on securing everything. Imagine trying to keep track of 26,000 pennies. That'd be how many dollars? 26,000? $260 for the pennies? It's a lot of pennies. It's truly a lot. And if you think about it, the reason why there's so many data breaches nowadays is because trying to secure every portion and every facet that an API has is almost impossibly difficult. There's only so many things that you can do, so many layers that you can create. And in the end, that is a main part of cybersecurity nowadays, is trying to enforce API like authentication, authorization, all of these different facets, which we will also talk about pretty soon. So I guess getting more into it, the benefits of securing an API there's 5 main facets of it, and that is saving costs, better customer service, improves industry level collaboration, gathers data for business intelligence, and also creates new revenue models. So kind of giving examples of all of these, a really nice part about having external APIs and using external APIs is you get to use another company's API versus building it in-house. So let's say you are working with the Atlassian suite, which includes Jira, Trello, Bitbucket, stuff like that. Instead of having to create all of that from scratch, you're able to use their APIs and use it for our 4th point here, and gather business intelligence. So you can look up story points, how it tracks with Trello tickets, etc. And in course, let's say Atlassian, for example, they get to create a new revenue model where they get to sell their API to companies, so companies can use this for their own BI or business intelligence, which in turn goes into point 3, where this improves industry-level collaboration or B2B, business-to-business connections. And in the end, your customers can be businesses or clients, anyone that needs to use your resources. However, the vulnerabilities come in play when malicious hackers come into picture, because hackers love APIs. If you think about it, APIs are literally sources of data that hackers can use, and if they're able to bypass the security systems or security measures there, they're able to get through everything. They can get your entire company's data for that specific API, and if that API isn't secure in between APIs, they can take a hold of your entire company. They can get so much data, and that is why it's so important to secure APIs. All right. So a castle. So some application security design things here is that a castle with no moat and multiple openings is a great representation of how networks work nowadays. If you think about it, back in the day, the only networks that were secure were ports 443 and 80, which were HTTP and HTTPS, or that is the Hypertext Transfer Protocol, and then with the S, it's with security. And those were the most common ports used and that were needed to be secured. So nowadays, if you think about it, whenever you're building an API, like the API we built yesterday, we used port 3100. Most modern applications or like security measures won't automatically catch that. In fact, if you wanted to expose that into the world for people to use, you would have to open up that port for the world past your firewall. So in the end, trying to secure all of these different features is very difficult, and it's really hard to mitigate them, which is kind of where the entire field came from. And once again, another problem comes with changing formats, income formats. So if you want to think about it, from the API we created yesterday, we allowed a variable amount of data or parameters to be used. And with these parameters, there were no security on them. And also, you could change in that in the update request, you could change the size and length and dimensions of the data request. So you can have all of the different attributes, or you could have a singular attribute, or any combination thereof. So in the end, having a changing incoming data format makes it even harder to make sure that it's not changing anything. Yeah. And then lastly, clients may not use a web browser. This is something that's often overlooked. Mobile and desktop web browsers are not the same. They act completely differently, and same thing can go with any other external service that is using an API. Nothing is static, and the security levels measures that are on our browsers may not be on actual external APIs. So external APIs, or APIs that you can code yourself, won't be the same. And that is part of the reason why it is so hard to secure applications like this, because you may assume some headers, what's it called? I think it's not user auth, it's something like that. Anywho, yeah, I'll get into that whenever we get into that. Sorry about that. All right. And some fun facts here. As far as API security risks, the biggest risks, or 55% of security vulnerabilities, or anything that happens with a API getting into, or like being broken into by a foreign actor, 55% are data breaches, 46 are accidental data exposure, 36 is deprecated AIs that are still alive and online that were forgotten about, 34% are shadow APIs, or basically APIs that are undocumented, unaccounted for in organizations or just in general, and then 31% are account takeovers. So that could be a user with elevated permissions, or that could be an internal actor, like an employee whose credentials were leaked. But yeah. So to mitigate these security risks, there are, I think, 7 that I have listed here, and these are probably like the biggest risks that are often overlooked. And these are really important if you're ever designing an API, and for any of these use cases, to make sure that you look into it and make sure it's secure. So the first being insecure pagination. So for those that are unaware, imagine that you're trying to build an application and it has a table, right? And or imagine what's an application that has a table that everyone can view? Imagine YouTube. When you're scrolling down through YouTube and you're trying to get all of these recommended videos when you're on your home, whenever you're actually querying the data, you aren't querying every single video that you can look for all in one query. The way it's working is through something called pagination. And the way that works is essentially it loads page 1. Whenever you scroll down a bit more, it loads page 2. When you scroll down a bit more, page 3, and all of those are paged requests. So a kind of description of this would be exposing PII, or personal identifiable information, through paginated API endpoints, which has a problem of being able to be scraped, which means that, let's say YouTube, for example, their entire business model is they have all their videos and all that video data. If you have a scraper that's able to go and crawl through all these pages without having to use their UI, they can actually scrape all the information, which leads to, it's a vulnerability, right? YouTube does not want you to scrape their API, nor does any other service. And a solution to this would be to rate limit resources and track the number of items the user uses. That way that if they're using too many resources within a time frame, they get blocked. So an example of this is sometimes you might get, if you're opening too many tabs at once, Google might ask you to solve a CAPTCHA to stop you from going too fast. Next is insecure API key generations. So a massive pooling of API keys by hackers can circumvent security measures meant to detect abnormal behavior, which basically means that imagine that you create an API and you're distributing a lot of keys, which is a project that we'll be creating today. We're going to be using JSON Web Tokens, which are a form of keys. If you have these free keys going out, hackers can actually get a massive pool of these keys and use them to get into your API. Yeah. And a solution would be to require human verification whenever accessing sensitive or secure resources, which could include two-factor authentication or CAPTCHA for any time you want to generate an API key, which exploits bots trying to request a bunch. Next is accidental key exposure. So this is probably a pretty big one, and that is API keys are prone to leaks due to their static nature and accidental sharing by developers. So imagine that you have an API key and you're building a project that you want to use ChatGPT in. What you're going to do, or what you probably have done in the past or might have done before learning about .envs, is you probably included your key and hard-coded it into your code, published it to GitHub, and made the repository public. And in doing so, you're exposing your private key that has access to your account and your money. And that is something that I see so much nowadays, especially with OpenAI and Gemini keys all over in hackathon projects. So don't do that. Make sure to use .envs, secure your keys, and don't publish them on GitHub. In fact, GitHub should be sending you emails every time you do so. And a solution to this would be to have a dual token system, which refreshes tokens for generating short-lived live access tokens to minimize risks. Or essentially what that means is whenever you're generating a token, that main token is going to authenticate a smaller token, which will have a time or a lifetime. That way that it will automatically expire and force you to generate a new one. And this can be seen whenever you authenticate using, let's say if you ever see sign into Google, sign into Apple, sign into GitHub, sign into Discord. 1 second. Must have done it before. Don't call this out that way. I've seen it happen so many times. Every hackathon I go to, I find at least 8 open API keys. It's wild. And then requesting a copy of the slides. Yeah, no problem. I'll send it after the presentation today, and it'll be in the same place as I did 2 weeks ago, or 2 days ago. Yeah. Just getting back into it. Yeah, so the way it works is imagine you log in with Google. Google's actually going to return to you through OAuth a JSON Web Token that has a time to live. And let's say it lasts a day. After a day, you're going to have to re-authenticate with Google to get a new JSON Web Token, and the new JSON Web Token will then be allow you to authenticate. Another instance might be if you ever try to get a GitHub PAT token. I think is a protective access token. Let me look it up real quick. I forgot what it stands for, but a GitHub PAT token essentially is something you can use if you ever want to utilize GitHub's API, let's say with your own projects or such. It is definitely a thing that it's a security measure, and whenever you try to create a token, it has a max of, I think, 2 years that you can use it for. So, but they recommend 1 month. Yeah. The next is DDoS attacks. So DDoS is something you've probably heard of, which is distributed denial of service attacks. And these basically mean that you have bots or a botnet that will constantly will constantly send phony traffic or just garbage traffic to an API and try to overwhelm it so that no one else can use it. So it's trying to take it down, or take the availability down, which is part of the CA triad. If any of y'all are familiar with security or information security, basically working with the the availability side of CIA. And then the solution to that would be to enforce API key requirements for any access. So essentially, if you ever want to use an API, you need to get an API key for it. And that way it makes it a lot harder, especially when paired with number 2 here, where you require human verification before you get a key. So it helps a lot. Next is wrong server security. So misconfigured SSL certificates for accepting non-HTTPS traffic can lead to data leaks. This is something that's often overlooked, and most people don't have familiar with SSL certificates or secure socket layer certificates. And that essentially means that you're misconfiguring it and you're accepting traffic that is not through HTTPS, and HTTPS is secure, it's end-to-end encrypted. So you're allowing unencrypted traffic, which could lead to data leaks as it's not secure. So imagine that you're logging in through McDonald's Wi-Fi and you're trying to go to the site and it's misconfigured. Even though it says HTTPS, it's not through HTTPS, and as such, people over the Wi-Fi will be able to pick up on your signal and take your data. So the best solution to this is to utilize SSL test tools to block all non-HTTPS traffic and add a load balancer to ensure that all data transmitted is secure. Next is insufficient logging. So essentially, so a delayed breach detection is often due to inadequate logging and tracking of API requests. So basically making sure that you log everything. If you log everything, you can often backtrack, and whenever there is a breach, so let's say that your security measures failed and people were able to take data when they weren't supposed to, bad actors were able to do stuff. You want to make sure that you log every single access and access point. So if you guys remember yesterday, I implemented just a quick logger to log every time that a resource was accessed and what type of query was being made. And with that, it allows you to backtrack and triage what happened and figure out what the problem was and go back and fix it. So implementing detailed logging is really, really, really important. In fact, in like a project I've made recently, I worked on creating a logger that had 3 different outputs: an output to a file, an output to a cloud database, and an output to the console. And what that allowed for is triple triaging, where we're able to have a actual solid file or physical evidence. We're able to have on cloud, we're able to access the logs anywhere. And then we're also able to view it in console when developing. So it is a very important thing to have, and having a good logger will expedite your not only development process, but also security. Lastly, not handling authorization. This is so important. Confusing authentication with authorization can lead to unauthorized access through iteration of object identifiers. So just essentially, we'll talk about this in a bit, but authentication is allowing someone to come in, while authorization is saying, are they allowed to use this resource? So you can be authenticated to use Gmail, but do you have the permissions that maybe a Google admin does, where they can view, or let's say a work admin for your email, where they can actually edit stuff at a more fine-grained detail that you probably don't have access to. So the idea is that essentially, if you don't handle authorization correctly, bad actors can just iterate through and basically hijack anything they want. And the solution to this is to validate authenticated users against ACLs, which is, I think, authentication control lists, I think, or I forgot the name. Let me look it up. I had it just on the top of my head. Access control list. Okay, I was so close. And basically using that to ensure that they're authorized to the requested resources. All right, that was a lot. Those are a lot of security risks and how to fix them. I'll also be posting these slides afterwards, but these are like the bread and butter of things that are often overlooked and that I have found in my time of creating APIs to be vulnerabilities. So now, talking about best practices and getting into more PowerPoint stuff, basically, how do we work to implementing different types of security measures to make sure that we're implementing best practices and making sure that we prevent anything from happening in the future. So the first and foremost thing to do is to have a vulnerabilities assessment, which is basically a regular, there's even more. The list for potential vulnerabilities is infinite, to be honest. If you go to Sneak, which also, if y'all have been to a hackathon, I think 2 years ago, Sneak was a MLH partner, but Sneak has a really good way to, that and OWASP, to track different vulnerabilities and their different facets and their different, what's it called? Vectors? I think attack vectors is the term for it. Yeah. So a vulnerabilities assessment is essentially the regular tracking of API lifecycle to identify and address insecure areas. So essentially, you have a list that you go through that is predefined by a company and or like whatever you're using. It's a list of just things to go through and to make sure that you touch on every one of them. And you just go through this, and as a solution, it just treats APIs as evolving software artifacts, focusing on stages like maintenance and feature deprecation, which is kind of it's like a solution or what comes out of it. It's the fruits of a vulnerability assessment. So it just helps. It's part of like a life cycle management that a vulnerability assessment works with. From where can we access the slides of this session for later review? Yeah, you can view it in the MLH Discord. If you go to discord.gg/MLH, after getting in and going through the onboarding, you can add the role for Global Hack Week. And with that, you can go to the Hack Together chat, which after this, I will be publishing the PDF version of this. 404 not found. I've lost a Lego raffle and Sneak raffle, or the Lego set in Sneak raffle so many times. Bro, you and me both. I have also lost that raffle, I think 9 times now. I have never won the Legos during that. So you and me both. Maybe one day. Hopefully they come back or get another Lego raffle sometime soon. There's actually another raffle going on with MLH right now. If you go to hackathons that have the Propel Auth activation. Propel Auth, or actually no, it's Sauce Labs. If you have a Sauce Labs activation, Sauce Labs now at different hackathons will basically ask you to use their security testing platform, which is free and also really easy to use. It can be done in 5 minutes. Really intuitive. I might show it even here afterwards. Basically, if you do that and take a screenshot and put it in your dev post, you'll be entered in for a Sauce Lab raffles, which has one of the best backpacks I've ever seen from MLH. It feels like Patagonia and it looks like Patagonia. You get a beanie and then you get hot sauce shipped straight to you. So it's honestly awesome. But it's no Mandalorian helmet. Oh, you won it in the very end? GG, bro. It was 14 times for me, but I won the last time. Hey, that's nice. And then I won the very next raffle, but gave it away because I had already won. That's nice. 14 hackathons is a lot. How many hackathons have you been to? That's awesome. I'm gonna take a sip of water real quick. Oh my god, 50 plus? Jeez. That is a wild amount. I've only been to... I just recently completed my 26th this past weekend. So you have twice more than me as a minimum. That's awesome. Yeah, all right. All online except one. Oh, I see, yeah. Hey, online ones are still fun to attend, and you can still get cool stuff from them. But one in person, that's pretty good. If you can, and if you have any available near you, I would highly recommend going to more in-person ones. They're so much more fun. I think in the India region, we had one this past weekend called Hackbite 2.0. So yeah, there are a lot of cool hackathons. There's always around at least 2 per month in India. So yeah, they're always a lot of fun. All right, for number 2, we have OAuth for access control. Essentially what OAuth is it's an entire architecture for security authentication between 3 different parties where you have the client or whatever you're using it from. So let's say your device, a desktop computer, a mobile device. You have the actual server of the application. So let's say this is Google. No, let's say this is an application you're building, a website, and it has a third-party authorization service, which could be Google, Discord, Apple, GitHub, etc. All these different things where it's like sign in with Google. That's OAuth. Or more accurately, OAuth 2, which stands for Open Authentication. And it bridges most security gaps as far as API authentication and authorization goes, as it allows you to fine-tune permissions from the third-party provider, and the third-party provider will also prove in authenticating you. So in both ways, it helps bridge a lot of these problems, and it's one of the best solutions for modern web apps you can get into. But as far as how that works with APIs, it's a little bit harder and a lot more harder for the user to use. And as such, what's recommended is to use OAuth 2 to create an account. And if y'all remember from number 2, insecure API key generation, which the best idea to do is you have OAuth 2 to log in. From then, you can create and generate an API key because you're authorized to do so. And with that, it's going to generate an API key that has the permissions of that user from that account. And from then, it's going to work with number 3 of generating a short-lived key for you to use in the form of JSON Web Tokens. So in the end, that is the best way if you're building a full-stack application with an API for public source use to authenticate it and make sure that it is secure. And yeah, and it says right here, the kind of fruits of everything is implementing OAuth for token-based third-party information access without exposing user credentials. And yeah, that's one of the best parts of OAuth as well, because it doesn't give you the user credentials. The server never gets that. They only get what is authorized by the third-party service, which we can explain in a tiny bit. All right, next is token-based identity control. So the idea is that tokens effectively establish access controls tied to verification identities. This is kind of similar, or this is pretty much a JSON web token, because it is token-based authentication. And these are really, really nice to have because they're essentially a token or a key that you can use, and they are tied to a database that has a user, typically like a user ID, and the access controls they're allowed to have. So with this, they make it really easy to issue out tokens on a whim, as well as retract them and have a time to live or a lifespan to them. And what this provides is you're able to allocate unique tokens to identify or to identities for controlled and secure API accesses or access. Okay, I misnumbered this. This is supposed to be number 4. Oops, my B. I'm actually going to change that real quickly because it's going to bug me till time's end. One moment. That's going to annoy me for the rest of the presentation if I don't get to that. All right. Oops. All right. Okay. Let's get back into this portion. Oops. That never happened. All right. Number 4 is okay. So number 4 is data encryption and the enforcement thereof. The idea is that TLS, or top layer security encryption, is crucial for the secure transmission of API data. This is basically a standardized encryption that you use whenever you access pages, or just in general, whenever you access and talk to an API. You want to make sure that your traffic to the API and coming back is encrypted. So this isn't about authorization or authentication, where you're basically trying to verify a user and accessing a resource or accessing it with permissions. The idea here is that you want to ensure the encryption of your traffic to the API as well as back. So if you want to think about it again from the McDonald's, McDonald's analogy, imagine you're at McDonald's and you want to access a very top secret secure NSA API. They're going to want to make sure that you are accessing it through a secure line of traffic to make sure that no one can eavesdrop and pull from it. And part of that is also with SSL, which is actually commonly used instead of saying TLS, even though TLS replaced SSL, which we'll talk to in a bit. And it's basically authenticating it through HTTPS. I should also bold enforce. I didn't bold enforce because I was, it's basically, I'm bolding the noun here, but in reality, it makes it look shoddy. So I'll go ahead and after this, bold all of the titles. Oops. And then how do I do the 2 key thing from an API? Yeah, so I can explain the architecture in a bit. And if we have time, we're going to get at least the JSON Web Token thing working. But if we can, we'll get into OAuth 2, which we will talk about how to get these 2-pronged approach working. All right. And yeah, so basically utilizing TLS for encryption and requiring signatures for data modifications and decryption. That's just jargon for saying that you want to make sure that all traffic to and from APIs, from you to the API and backwards, is all encrypted to make sure that eavesdroppers can't steal your information. I'm gonna take a sip of water real quick. All right, number 5 is rate limiting and throttling. And what this does is increases stability of your API or infrastructure. The idea here is that let's say you have your own API and it's running on a Raspberry Pi, right? And with this Raspberry Pi, you might know that the compute power isn't very strong and it can't take too much network traffic. So the idea here is that the best way to actually use a Raspberry Pi as an API is to implement rate limiting and throttling to make sure that no user can bombard your API and prevent other users from accessing the information. So the best way to do this is to track how frequently or within a time frame how much a user has requested a resource, and basically limit them to only using so many resources within a time frame, and giving them that essentially sliding window, or you can do per day, whatever time frame you want. And this prevents users from sending requests that would just end up reducing availability for other users, which also prevents DDoS attacks. And what this does essentially, the pros of this is that it implements rate limiting and throttling to balance data access with system availability. And then next is API gateway enforcement. So an API gateway centralizes API traffic control, monitoring, authentication. Or if you want to think about it, or I guess for those unfamiliar with cloud architecture, or AWS load balancers, ELVs, elastic load balancers, essentially you want to make sure that all traffic goes to one centralized point. That way you're able to secure and authenticate at that point. And if authenticated, it can go into the actual APIs. So imagine it as like a firewall per se for APIs or for any incoming traffic, where they have to hit that gateway. And if they get through that gateway, they can go to the actual API resource. And the API resource will take from whatever it needs. And also kind of bridging off of what we talked about yesterday. Yesterday, one of the rules for a REST API is that at any point in an API, it doesn't have to know who the user is or who the receiver is. So you could have chains of APIs, for example, because of the way that REST is architected. And a solution for API gateways, once again, is that it allows for a centralized authentication and traffic like control or choke point, which regulates API usage for all users, rather than having an independent system for every single API you have. And if you all remember, the average organization has 16,000 plus APIs. So imagine having to authenticate at every single one of those APIs. It's a nightmare. That's why most companies and most organizations and enterprises utilize a gateway. That way everything goes to that choke point, and then it goes to the respective resources. And our last two here is service meshes, which allows for enhanced management. Essentially, what a service mesh is it as a management layer for routing requests and optimizing service interactions, or it's just a management layer, if you want to think about it, for how to control and monitor and optimize requests. So imagine you have a massive API graph, talking like computer pictures here, or imagine like a massive mesh of APIs that intercommunicate with each other. These could also include clients, like your desktop computers or anything like that. And let's say you want to access I guess I can draw here. Let's draw. Imagine that you had a massive graph, right, of stuff all interconnected to each other, and it's connected like this, right? So basically this graph of what can communicate with each other. So the idea is, imagine that you are here and that you want to get to here, right? The idea is that a service mesh will basically dictate the route to take, and it takes into a lot of account of how long does a resource take, which one has the most traffic right now, which one is balanced, which one's the quickest, which one is the best, which is the most optimized. The idea is that it's going to find the route that is the most optimized for any user or interaction possible for this API, any interfacing to your API system. So the idea is, like, imagine that this first node right here is your gateway. Your service mesh is going to work with trying to route you to any type of request. So That's the idea there. And lastly, zero trust security model. This is so incredibly important when designing or even thinking about how to architect a security model. And that is, the idea behind it is that the complexity of networks necessitates a shift to a zero trust model, focusing on resources and users, or essentially, you want to operate a model where no one is trusted. You don't trust anyone. And as such, no one has access to anything at the very beginning. The only way you can get access is by actually authenticating yourself upwards and elevating yourself with different permissions. So the idea of a zero trust framework is basically, so basically trying to just build upon how no user has any trust at the beginning, but you can build up trust and act with the more authentication and authorizations that you have. Or, as this is over here, moving security emphasis from location, specific resources, and user credentials. Okay, so taking a quick breath, those are the best practices as far as it comes to designing any type of API that you should always keep in mind. Yep. Sorry, my voice is getting a little bit raspy from talking for so much. All right, and never mind. We actually have two more. LOL. All right, last two. So okay, another one is validate parameters rigorously. This is probably the most important thing that you'll ever be using whenever creating an API. This is the last layer of defense whenever it comes to accessing an API, and that is making sure that you validate your parameters regularly. This is the main vulnerability that comes with any type of API that you will ever make or use. And the idea here is, imagine that you are creating a login form for a user to log into your website with, right? Let's say a user tries to SQL inject and they type the following into your prompt. They type in a backslash, they type in a 1 equals 1 or 1, and then they'll do like a hashtag, and then 2 dashes, and like maybe this, maybe a quote. And the string is essentially trying to just say that, okay, whatever you're getting, respond with true, and comment out the rest of the code. So the idea here is that's the biggest example, which is SQL injection, where a user is able to basically, because the parameters aren't validated, they can just put that in, and then the code that you're taking from your API is going straight into an SQL query. And from then, they can basically just bypass a lot of security measures. So the idea here is that whenever you have parameters, you also have examples like edge cases. So imagine that you get a 0 and then you suddenly get a divide by 0 error. And in such, let's say this is a banking application where they're going to give you divide by 0 amount of dollars. You might be able to break it depending on how you architected everything to give you an infinite amount of money, a negative amount of money, 0 amount of money. It could essentially break everything. So the idea here is that you want to validate your parameters rigorously to make sure that parameters aren't able to add junk and get away with stuff or create unintended consequences or artifacts in your code. And lastly is threat modeling. It's something that you'll see probably if you're going into the field of cybersecurity, and that is trying to model out approaches and use them as test cases. So whenever you model out these approaches, you're able to actually, in your architecturing phase, or whenever you're trying to readdress something, you're able to fix a lot of these issues preemptively. And yeah, that is basically the entire thing. You want to regularly conduct threat modeling attacks. So an example of this is if anyone has seen Thor from Pirate Software, the YouTuber. He's been pretty popular in the YouTube Shorts sphere, and I think he was at the Streamer Awards recently. But one of his best examples is at Blizzard. He did a lot of threat modeling attacks where he would pretend to be a janitor, get in through bypass a lot of security measures just by social engineering his way through. So that's an example of threat modeling that you might not think of. It's not exactly software-sided, but it is a lot of times software-sided. So modeling out your attacks is a very good way to reassess and reevaluate everything. That way you take a preemptive approach to identifying risks. Let me read chat real quick. So you're telling me my Jake code won't fly in production level deployments? No, it won't. As much as I really wish Jank code can fly, it doesn't. Actually, there's an asterisk there. It can fly if it gets approved, but typically it's best practice not to. But we ball. Otaku Lilu said, "What's the name again?" Oh, his name is Pirate Software. So if you Google Pirate Software, like Pirate Bay and then Pirate Software, you can see he's a Twitch streamer, but also a YouTuber. Really, really good at game design, and he worked for Blizzard, I think Amazon Games for a bit, and he's an awesome YouTuber if you ever want to learn a lot about cybersecurity while having fun at the same time. Yep, for not founds on top of it. Yep, that's the one. Awesome YouTuber. He's a lot of fun to watch. He provides so many insights, which is really awesome. All right, and that is the end of the security practices bit of the entire presentation. So now we're getting more into what we'll be using, and we'll be using. Sorry, not what we'll be using, but something that you'll probably understand a bit more. So for those familiar, everyone here has used a link that uses HTTPS, or the Hypertext Transfer Protocol, with security. And what that essentially means is the S in security is actually SSL, or what is now TLS. So you may ask yourself, what is SSL? Why do I constantly see this padlock next to my thing that's green inside of Chrome? Why do I need to use HTTPS, and why does HTTP always give me a warning? And the answer to that comes in SSL. So you may ask yourself, what is SSL? Secure Sockets Layer, or SSL, refers to a protocol for encrypting, securing, and authenticating communications that take place on the internet. Very broad overview, but essentially it means it is the encrypting algorithm and encrypting service that everyone uses when using web traffic. I just realized the banner is not up right now. This is not correct. I'm gonna fix this banner real quick. I'm actually going to take this moment to do a quick plug. For those that have not already, don't forget that it is the end of Global Hack Week today. There are only, I think, 3 other sessions after mine, and that means that if you haven't already, please be sure to sign in. Even if you've already signed, or if you meet the minimum to get swag, please sign in. It helps me and helps basically show what I need to, shows like what topics are really good and what we need to continue at future Global Hack Weeks. So if you haven't already, please sign in. But yeah, was under a rock. I didn't know SSL was replaced. Yeah, SSL technically isn't replaced. Replaced isn't a good word. It's updated. It is replaced, but it's kind of replaced feels so harsh. It's an updated protocol, which has since been, which is TLS, or Transport Layer Security. Thank you, y'all. Appreciate the sign-ins. Yeah. So SSL was replaced by an updated protocol called TLS, or Transport Layer Security, though SSL is still a commonly used term for this technology. Typically, whenever you say SSL, you're actually referring to TLS, because TLS was the replacement for SSL. Yeah, TLS is basically the updated protocol for SSL. SSL is very old, but SSL is just used everywhere because it stands for Secure Socket Layer, which is the exact same thing. It's just whenever we changed the network layer and added that, we added TLS, or the security layer. What am I saying? Not TLS. Sorry, the transport layer is TLS. Yeah. So it's a network diagram, or network datagram. Yeah, and the main use case of SSL, or TLS, is securing communication between a client and the server. But fun fact, it can also be used to secure email VoIP, or voice over IP protocol, and voice over internet protocol, and other communication over unsecured networks. And the reason for this is it's giving an example of using TCP and UDP, or basically something, or guaranteed transfer or non-guaranteed transfer, and it's used everywhere essentially. TLS is the definition of our encryption standard that we use today whenever we communicate on the internet. So a lot of people don't know what it is, but it is very important It's a very important part of everything we use nowadays. So now you might be thinking, okay, so SSL TLS basically secures our traffic, but how does it work? So I'm going to try to explain this as understandably as possible, and I'll have a diagram at the very end of it. But try to bear with me. If you haven't been paying attention, try to pay attention for 2 minutes, and I'll try to get this pretty fast, but in an understandable way. So, secure communication begins with a TLS handshake. So, about this in terms of cybersecurity, think of it as in a person. So let's say you're meeting with someone else, and you're shaking their hand. That's a handshake, right? Same thing could be said whenever a client and a server, or you and your application, are talking to each other over internet. You basically want a handshake in person. You shake their hand, and in shaking their hand, you give them, let's say, an envelope to transfer your information. So doing so, you know exactly who the person you're shaking your hands with is. You know where they are. You know they're there, and you know that you can trust them once you've seen them and you've authenticated them in your mind to give them the information over. Then they take it, and then you both part ways. So that's the exact same thing here. That's what I mean whenever I say handshake. So basically, two communicating parties open a secure connection. So meeting together in like a private place and exchanging the public key, or let's say this public key envelope. You're passing this and you're saying, this is my public key. And if you're unfamiliar with public key and private keys, I'll explain it in a little bit, but just try to think of this public key is, you don't want per se everyone to know what your public key is. But whenever you communicate with somebody, you want to give them your public key just as a way for them to know who you are. Awesome, 404. Thank you. So it feels up how firm the handshake is, basically. Yeah. If it's a firm handshake, then you give the information over pretty much. Yeah. So now that we described how that this connection begins with, let's imagine that the exchanging of the public key is whenever you see the other person. Whenever you see the other person, you give them a, I don't want to say envelope per se. I realize now that's probably not the best analogy. Let's say you give them your business card first, right? Your business card, anybody can use, but you don't want to give it to anybody per se, because let's say a spammer or a spam caller takes it, then they'll just spam you with junk emails. So you give it to people that you trust, or anyone that you know will have a legitimate communication with you. And that's this beginning handshake portion. And now during the handshake, both of you generate session keys. And I guess in this analogy, the best way to explain what a session key is imagine it is, what is a good idea for an analogy? I'm trying to think right now what a good analogy for this is. Okay, let's just say that both of y'all have a secret code that you want to exchange, right? And the goal is the secret code is going to help you make sure, again, next time you meet, you have to say, okay, what's the secret code, right? And think of it like, let's say you're okay, this is not a great example, but let's say you're at a secret place and you have to give a secret code to get in. That's kind of what this is. You're basically generating two secret codes that you're making up for each other to use, and that's going to be your session key. And what these session keys will do for the specific person, and because once again, when you get passphrase with one person, you're not going to have the same passphrase with another person, because you want to make sure those are independent, right? Just like, what's the secret word? What's the secret key? And what these will do is you use these session keys to encrypt and decrypt all communication after the TLS handshake. So after you gave your business card and he gave, they gave their business, you know exactly who it is. You had that handshake. You know everything, like it's okay, they're the right person. You generate a passphrase, which are session keys, and this session keys are going to essentially encrypt and decrypt any communication back and forth. And once again, different session keys are used to encrypt communication in each new session. So I guess another thing is, let's say that you want to make sure that you generate a new session key anytime you communicate with them after you use it one time, because let's say somebody overhears you, you want to make sure that when they hear that they can't easily spread it to another person who will then permanently know your secret passphrase. So you change your passphrase every time you talk to them. So that's the same thing here. You generate a secret code that you tell them, and whenever you communicate again, you will expend that secret code, and then you create a new one. That way, every single time you have a new code, and if someone has your code once, they can't get it again, or they can't use it again because it's expired. And with that, TLS ensures that the party on the server side, or the website the user is interacting with, is actually who they claim to be. So after I get to this part, I'll explain how it works in the context of websites. But continuing with the secret code analogy, TLS also ensures that data has not been altered if the message authentication code or a MAC is included with transmissions. An idea for this is, let's say your entire transcript of what you talked about, or let's say the package you're delivering or the envelope that you have. Let's say you have a second envelope, but this envelope literally is an encryption or like a encoding of that entire message you're giving. So if let's say that someone tries to fake being you, they aren't going to know exactly how you encode that message with, because you encode it with your session key. So in the end, their encoding envelope is going to be wrong from their real envelope. And that encoding envelope is basically the MAC, or the message authentication code. And then with TLS, both HTTP data the users send to a website by clicking, filling forms, etc., and the HTTP data that the website sends to the users is encrypted. Important. Both HTTP data the users send to a website and what is sent back is encrypted. And that's the entire idea of TLS. It's encryption both ways. And then the encrypted data has to be decrypted by the recipient using a key. So anything you send to a website is going to be you encrypt it with your public key, which they also have. And then anything sent back, the only way to unlock that package is to use your private key. So when you're giving this envelope to the website, whenever you go onto this website, it's going to automatically give you their public key, or their public key. So you encrypt the envelope with your public key, but also encrypting their public key. Oh my God, let's start that again. So whenever you send a message to a website, kind of getting away from this analogy we've been working on before, you have their public key, and that is their SSL certificate per se, right? You use this, you encrypt your envelope or your message or your request, whatever you're sending, with their public key. When they receive it on their end, they have to decrypt it with their private key. So basically anything encrypted with a public key can't be unencrypted with a public key. It can only be unencrypted with a private key. So there are two different keys that when encoded can only be decoded with the other. So the idea with this is they are the only ones that can open it. But to ensure that you know who they are and they're the right person and they're not lying who they are, you have the initial TLS handshake where you exchange business cards and you basically establish that secret code. So using this, that's how they establish a secret connection. And this is used every time you make a request. And lastly here, yeah, I'm going fast. Sorry about that. I'm going to explain it this way. This way is a lot better. I just realized I was there. Okay, so this is the explanation part of it where I'm going to be trying to explain it a lot better. I'm going to be explaining to y'all how public key cryptography works, which is symmetric encryption. Yeah, which is how the web works. Yes. Yeah. Okay. So essentially here, you have two keys, a public key and a private key. The public key is what the server makes available publicly, and a private key is what only the server has. So data is encrypted with the public key and can only be decrypted with the private key. So the idea here is, let's say you have your original text and you have a key. In this example, they're using a symmetric key where both of these are public keys. I think I forgot to put an example of private key encryption, but private key encryption is built on top of public key encryption, where they have data, you basically encrypt it with this key, and then you have a ciphertext, or let's say your encrypted stuff, and then you can decrypt it with the same key. The idea with public key and private key encryption is that it's the exact same thing, except you have two different keys for encrypting and decrypting. The public key is what everyone gets, and the private key is what only you get. So everyone encrypts it with your public key, and they decrypt it with their own private key. And whenever you send it back to them, you have to send it back encrypted with the sender's public key, and the sender, or the one who originally sent the message, has to decrypt it with their private key. And that's the idea between basically asymmetric and symmetric encryption, or public key, private key encryption, which private key encryption is what SSL and TSL runs on. So yeah, that was a lot. Y'all are probably not going to understand it at first hearing, but I would highly recommend looking a little bit more into it, because hopefully this gives you a pretty good jumpstart into learning about the world of cryptography, which is a fun thing to do, especially when you go to CTFs. And then, yeah, now getting into how it works specifically with SSL and that, I think there are 3 more slides and then we have a break. So SSL TLS, basically what this is SSL certificates are the essential for encrypting website traffic via TLS. And how it works is you basically install an SSL certificate from a trusted certificate authority or a CTA certificate authority for website security and encryption. So essentially, there's this certificate authority. For example, what you see a lot is Let's Encrypt 3. They're this authority that assigns certificates, and they assign it to different websites that use HTTPS or SSL. And whenever you access the website, you are getting the certificate, and that is their public key, essentially. And to obtain an SSL certificate, they can be obtained from any certificate authority. The most popular, if you want one for free, would be Let's Encrypt 3. And they basically validate ownership, website's ownership. And what this does essentially is you request and install a certificate from a CTA to authenticate your website's identity. And then, once again, talked about earlier, free SSL certificate options. Some organizations like Cloudflare and also Let's Encrypt provide SSL certificates for free of charge to promote a more secure internet. And utilizing services like Cloudflare or Let's Encrypt, free SSL certificates can be used to maintain optimal website performance and security. And tying this all back again, the difference between HTTP and HTTPS is that with the S, that is the more secure version of HTTP, as it incorporates SSL and TLS encryption for safe and authenticated web traffic. And yeah, that's pretty much it. And this is an example getting into authentication versus authorization. Sorry, context switch. Authentication versus authorization. We've talked about authorization and authentication a lot during this session, and I'm here to explain a little bit of what the differences are, because mixing up these differences will result in vulnerabilities. They always will. Messing these up are so confusing. Yeah, I'm so sorry. In interest of time, I have to speak very, very fast. We only have 45 minutes left, so I'm trying as fast as I can so we can get to the coding portion. So I'm stumbling over my words a little bit as there's a lot of content to cover. But just real quickly discussing the difference between authentication and authorization. Imagine that you're over here. This is, let me zoom in actually. Imagine you're here and you are the client. You have an authorization server, an API service, and API keys record. As a client, you're going to be sending a message to the authorization server. The authorization server is going to give you back an API key. And from this API key, you're able to use this request that you have, plus the API key to an API service, and then they will authenticate you, send it back, and with that, send it back, and then they will also get anything from the key records to authenticate that. We're doing it all over again. Let's say you have a request. You need to get an API key from an authorization server. With that, you can send a request with the API key. The API service will then validate the API key with the API key records, and then it will do whatever it needs to authenticate your thing. So authorization is first, then it's authentication in this scenario. Or an example of it visually, the difference between the two is that authorization is, can you do that? And authentication is, who are you? Best way to speak about it. Imagine, once again, let's say you use Discord and you make a Discord bot. It's going to ask you to select all the permission scopes you want. The idea here is you're authorizing what it can do. And whenever you have to sign in to actually allow the bot to be added to a server, you have to prove that you are who you are and that you have permission to add it because you're an admin of that server. So that's the difference. Authentication is who are you. Authorization is can you do that. And that is all for now. We have a 10-minute break at 2:25 Eastern, or I'm pretty sure is it 1:35 a.m. 1:25 a.m. One of those, yeah. 10-minute break essentially. IST, yeah. 11:45 a.m. IST. Oh, perfect. Thank you so much. Yeah. So in 10 minutes, we'll be back. So yeah, I'll be right back. Oh, BRB. All right, y'all. We're back a bit early for this one, but in interest of time, we're going to be moving a little bit faster. The goal here is to get all of JWT-based authentication up by the end of the stream, so let's see if we can do it. First things first, I'm going to try to catch up with chat. Some bio breaks break the toilet. What's the GoDaddy promo code? MLH GHW data. Don't, at least that is what the website says. MLH GHW data. Too much Mexican food is a great way to defeat the toilet. That is true. I tried this, but it didn't work. I don't know if that's to the toilet comment or to the MLH GHW data code. I think the code is broken right now. We're trying to look into an issue that crept up. Keep looking at the script updates. Yup. Sounds correct. I find Mexican food to be a bit sweeter, as where I'm from, India has a lot of spiciest dishes, but that might just be as it's Taco Bell. You can get some killer spicy Mexican food, not Thai spicy though. Oh my gosh, I am a fanatic for spicy food until it kills me. Yeah, Thai food can be pretty spicy. Same thing with Indian dishes, same thing with Mexican dishes. There are some killer dishes, but the Thai chili peppers, holy wow, those will just knock you out. Would highly recommend for those who haven't tried to try a Thai chili pepper in their lifetime, especially like a raw, ripe one. those will give you so much heat. All right. So let's begin with the coding session. So for those that weren't here yesterday, to join, go to hackpack without the K/code with Ryan, which is also the code that is in chat. Oh, you beat me to it. Dang, nice. Yeah. So go to hackpack code with Ryan. That is the code that we'll be using for today's live share, and we'll basically be watching me. And for any of those that are proficient in or know the concepts, be working through and creating and updating our Wonders API to work with authentication. So we can basically make sure that only users who are registered can use the API. So that code will continue to be pinned in the bottom left. But once again, in the interest of time, we're going to be moving from the PowerPoint presentation all the way over to the code presentation. So I'm going to go ahead and I'm going to stop the screen. And I am going to, a moment, and I'm going to share VS Code. Okay, so I hope everyone can see this. I'm going to zoom in a bit. Let me know. Oh, I don't know if y'all can see that. There we go. All right, let me know if this is too small or too big, and I can go ahead and change it. All right. I'll let you all come in, and what we'll be doing is we're first going to work on trying to overhaul this code, and then we're going to be, oh, sorry about that. Oh, no worry, Otaku. We're going to be moving to the coding portion. So if you want to join us, go to hackpack without the K/code with Ryan. It's also right there below me on the bottom left of your screen, and it will lead you to a VS Code live share where you can code with me in chat or code with me in the browser. And with this, we're going to be working on implementing JSON Web Tokens into our project from yesterday, which was a SQLite plus Express project. So yeah. Without further ado, I'm going to make sure I have chat open on the left here. So give me 1 second. Trying to get my screens all managed. Awesome. Okay. So let's begin. So the first thing that we're going to do actually is we're going to try to overhaul a lot of the code that we had before and make it more standardized and use a lot more cool stuff and cool packages to make this a lot more readable and a lot more efficient. So the first thing that we're going to do is I'm going to ls and I'm going to cd into the back end. Inside of this back end, I'm now in it. And what I'm going to do is I'm going to npm I SQL, if I can spell that right off my memory, npm SQLize. That's basically a database manager that's for Node, and it works specifically with SQLite 3, which makes it a lot easier to run queries on it. So yeah. So first thing I'm going to do is I'm actually going to require everything now. So I'm going to do a quick const Actually, do I need to do it here yet? I think. Do I? Is it const sequelize is equal to require sequelize? Is that right? All right, awesome. Yeah. So we have that, and we're going to work with Singapore database. So I'm going to go ahead and start commenting a few things out. Actually, to even begin with, so this is our main code. Once again, wait, give me 1 second. I'm getting a call. All right, sorry about that. I was getting a call. Okay, so first thing we're going to do is we're going to create a models folder. So yeah, so essentially we have this models object that we've used for our wonders, and we want to make sure that they're all standardized. So we're going to create a models folder so we can also model out what a user object looks like. And this is getting to more object-oriented paradigms. So first thing I'm going to do is I'm going to create a models folder. And in this models folder, we're going to have two different things. We're going to have one for users, so users.js, and then we're also going to have one for wonders. So we're going to call that wonders.js. So, getting a new request to join. In our users folder, we're going to basically create a module export for sequelize that defines a user object. So module.exports is equal to a function, and we're going to actually, we can even do it like this, sequelize, and then sequelize a my sound went away. Give me 1 minute, y'all. Someone's spamming me. All right, okay. So yeah, okay, let's check this out. So yeah, so we're creating a module.exports for sequelize, and now we're going to create a schema, and we're going to name it user schema. Oops, name const wrong. User schema. This is just going to be sequelize dot define, and we're going to define a user. I'm going to give them the name of sequelize. Am I spelling all of this right? Sequelize dot string. Oh, my hotkeys. Sequelize dot string. Then we're going to create a username, and that's going to be seq dot string. And then we're going to create a password, which is sequelize dot string. And then with this, we're also going to do a little bit of logging here where we give it a timestamp for access. Timestamp of false to begin with. And then with that, we're going to want to return user schema here. There we go. And that should be good now. All right. And now the next thing we want to do is we actually want to do the exact same thing, but for this previous schema object we created. So I'm going to go ahead and utilize the beautiful ChatGPT to do the exact same thing, but for wonders. So we can do a quick module.exports is equal to sequelize, and then sequelize. Finish the callback function, and let's give this a const of wonder schema. And I'm actually going to give it this thing over here. Comment that out, and this way ChatGPT knows how the wonders object is stored. All right, awesome. And then, oh, I forgot that. No, parenthesis there. All right, and then with this, we can see if ChatGPT can figure out the entire schema. There we go. How wonderful. ChatGPT is able to create this entire schema for us to use. However, it's giving us a colon expected. I think it's because of an imbalance of, where is it? Fine. Wonders. Get a callback there. And anybody spot the issue? Was it giving me a TypeScript error? Anybody know what the issue is here? I'm also a little bit confused. Did that work? What was the issue? I'm a little bit confused. Oh, did I forget a comma or something? That might be it. All right, and then we do a quick return wonder schema, and that should stop that issue. All right, lovely. So we've defined two different models that we can use in our database. So let's go ahead and also while we're at it, let's refactor and standardize the way we do routes. So let's create a new folder called routes, and let's have a routes for wonders. Oh, I forgot to name it .js, name.js. I actually don't know. Copilot just fixed it for me. I think it's because I forgot a comma. Where was it? I forgot a comma between these, I think, and that was why. I can check actually. Yeah, it's fine. In the interest of time, I'm going to try to zoom a little bit through. Okay, so for wonders.js, we have a routes for that, and let's also make a route for users. And these are going to be the two things that we use to interact with logging in and logging out. So I'm going to go ahead and close these out. And let's go ahead and while we're at this, let's refactor the way that we are doing our current stuff. So I'm going to go ahead and take away, I guess in better words, I'm going to go to index.js and I'm going to try to abstract away all of our endpoints to be in one centralized folder for all the same thing. So I'm going to move all this CRUD to its entire route or separate route. And do that. Go to users.js. And then we're setting to do all the imports again. So let's do const express equals express. Let's make SQLite there. Acquire body parser. And that should be it. I'm getting so many spam emails. Oh my gosh. Okay. Yeah. And with this, we should have all of our routes in here. And now all we have to do is manage these routes. But just to make sure, all we have to do is, now that they're in its own route folder, we're going to actually, I'll show you all how to make it where you don't need to have the slashes, /wonders, as it will do everything for you. It will handle that for you. So all we need to do is /ID and pretend that this entire route begins on wonder. So we don't need anything after or anything before. So going from /wonders to just this. And the reason why we're able to do that is back into the main index file, we can actually create a route here. I'll fix this in a tiny bit. That's a little bit janky. What we can do here is we can, we do need to initialize the SQLite database. So let's do all of that right now. So let's import models. So const models is equal to require /models, and that will import the entire models folder. And let's import our routes in const wonders is equal to require model wonders. And then the same thing with const users being the users model that we have. So now we have those models and we can use them the way that we defined them in SQLite. So let's also work on our database now. So let's make a sync database function. So it's going to be models.sqlize .sync .then, and what sync essentially does is it works with trying to just connect to the database in whatever capacity it can. So it's like a connection string. So then we have to pass it a callback using .then, and with that we can just pass it a callback function or a lambda, like I like to call it, and just do a console log. I'm actually going to name this connected to database. And then we can catch any errors. Let's do error. And then we can console.log error. All right, and now it should join itself. And then we can continue to have the app.uses over there. And we use JSON there. That's right. And then to make sure that the URL is all encoded, let's do app.use. That. And then after that, we can start registering our routes. So what we can do here is we can do, I just realized that these have to be below these. Oh, and logger has to be above that. Oops. Awesome sauce. Okay. So next thing we're going to do is we're going to register our routes so we can actually use them. So we can do a app.use and then give it the prefix. So wonders. It'll be wonders. And then we can do app.use, users to be users. And then that's pretty much it to load in stuff from our users folder over here on the left side. After that, we can do a quick, I think we already have it down here. We can have this app.get to test our main endpoint to see if it works. And after that, we have our listen, and that's going to listen on our port. And besides that, we have this chunk of code over here, which we will eventually get rid of. But for now, what's it called? I'm actually going to comment this out for now because it's kind of like junk. Yeah, so I'm going to comment that out for now. All right, and that will be our main app.js. So to briefly go over what we did, we created a models folder containing all of our object definitions or schema for everything. So for users, and we also moved all of our routes into a routes folder. That way we can kind of make them all independent of each other. And we basically connected them together with use/wonders with wonders, and it basically appends that to everything that's being used and loads all the routes in. So with that, we can actually start coding our routes. So the first thing I'm going to do is I'm going to actually code users. I realized I put this in the wrong folder. And we're going to code users, and we're going to do the exact same thing as earlier, but we're going to, I'm actually going to import all of those again over here. Right. And I guess as we're scaffolding this up, I am also going to show y'all how to basically implement GHW web tokens now that we've kind of cleaned stuff up. So first we're going to do is we're going to create a GHW check, and this is going to be how we check for GHW web tokens. But before we do that, I have to actually install it. So npm I JSON web tokens token, and then we do express-jwc. And importing those two things, we import basically what we can use or what we can use for JSON web tokens. So we can do ejwt, which is express JSON web tokens. And then with that, we can pass it in a secret, which is going to be, I guess, let me get an open SSL key. Open SSL 16, ran 16. Actually, for now, I'm literally going to mash my keyboard. This is. All right. Oh, doesn't need this. Octoliterals. Okay, there we go. So this is our super duper secret key that I just made from hitting my keyboard, but normally you'd want to use some kind of secure hashing algorithm to make a key. And then with that, we can create another function that we're going to use. I'm going to name it create token. It's going to do, actually, no, it's just going to be taking in a user. Oh. And it's going to return a JWT dot sign. Does that work? I forgot to import JWT. LOL. So let's import JWT, and that's going to require JSON web token. So now I should be able to sign it. When I sign it, I can sign it with a username, is user.username. And then I can give it a config. I'm not using a config. So I'm going to do a. I'm just going to copy and paste this key, or that copy. Do that. And then we're going to also, so it's the same key here. We're using the same secret. This is like our personal secret that we're using to authenticate our entire thing or encrypt our entire thing. And then we're going to give it an expires in, and we can actually just give it 24 hours. The secret value is any number that you create randomly. It's literally like, imagine it as you want to create a new key that you will use to hash your entire project. So it can be like 32 characters of random stuff. I just hit my keyboard because I'm too lazy to generate one, but you can use any tool to like open SSL. I think there's like a generate anything you want. Yeah. But yeah, you can just string there. So we made something to create a token. Let's create another thing to check ID input. Same thing, if you all ever get to use next auth, they make you do the exact same thing with setting up authentication there. Just a cool fun fact. So we're gonna check the ID input, and what we're gonna do is if we check if the parameter, this is one of the things we learned today, making sure that we validate our parameters. If the params.id is null, or is not null, no, it's null, we're gonna send an error. So res.status 400 invalid ID. Else we are going to next and continue on. All right, and then we're gonna make one to check if an ID exists. Check ID exists. Continue that, and wow, it pretty close. We need to import user. So it's actually gonna be user, I'm gonna delete this. It's gonna be user.count, and we're basically gonna take from here where the ID of rec.params, and then we operate on this callback. And what we do here is with count, we're gonna, if count is, it does not equal 0. Actually, this is fine, yeah. If count is equal to 0, we send an error, else we do next. And with that, we're finally able to start working on authentication here. So let's do router.use/, and we're going to make it use JWT check. And then we're going to give it a function request res next. And then if error.name is equal to unauthorized error, then we're going to send it a 403 actually. 403 is the right one for not authenticated. And then what is it? By status, I'm actually going to do a .send instead of .json, and we're going to send it basically a. We're going to send it a status false. We're going to give it a data, just to make sure our datagram is the same for everything and we don't get errors with consistency. And then we're going to give it a message of invalid token. And that will be our login route for if they're not authenticated. So that's our authentication check. Next, we're going to do router.get. Why is the router capitalized? I just realized. I hope that's not an issue. LOL. All right, router.get, and now we're going to get. We're actually going to get profile. And with this, we can have a callback request result. And then const decoded is equal to jwt.decode. So we're decoded JW web token, JSON web token. And it's going to be rec.headers.authorization.split. And then we're going to split on spaces. And we're going to take everything after that space. So normally it is going to be, whenever you pass it in, it's going to look like bearer space, and this is your token. So we want to split it up based on the space and only take this part of it. If that makes sense. And then after that, we're going to do user.find all. Find all. And then we're going to try to find users where the username is the decoded.username. And if we can, then we're going to what are we doing actually? We want to return the user object. Okay. Yeah, that should be right. Okay. And now we need a register and login endpoint. So we're going to do router.post/register, and then we're going to give it a rec-res, and then we're going to do user.create name, rec-body.name, username. We only have 13 minutes left to get this finished. Kind of on the edge of time here. User, and then we're going to just result status user created successfully, and then on error, not successfully. And then now we're going to make our last one, which should be our login. Probably the fastest I've ever implemented auth from scratch. Unfortunately, I can't provide access to terminal because it is my personal machine. Just for security reasons, can't do it. Sorry. Rec-res user.find, and we're going to pass it in this object where username is rec.body.username. Username. And then we're going to do a, if it is able to find it, then result, pass it to another callback if there is a result. Then we're going to, if there is a password that is equal to the password that you provided, then we're going to provide true, and then we're going to create a token. So I'm actually going to make this a ID_token. So a token works as well as our data. Status is true. And then we give it a message as successful. I think it might also be important to include the ability to see their username again, just for points of reiterating, or if you want to show it on the, what's it called? If you want to show it on the website, you might want to see their username. And else it's going to return an invalid password. Ideally, you actually don't want to differentiate between a password and a username if it's not found. That's security risk, but what I'm going to do here is I'm actually going to do invalid username/password just to make sure that everything's secure. And then I'm going to give it a data of ID token of nothing and username of nothing. And that'll be on the client to figure out how to present that. And else, if it was successful, or actually, if it wasn't even that type of error, we're just going to give an error of, sorry, this is for password. If it's not the password, it's going to give that error. If it's not the username, it's going to give the exact same error here. So we try not to say if it's user password, username or password error to prevent users from, or bad actors from, messing with that. And then we're going to do a catch for errors. We get an error. And then we're going to return a, just realize these, yeah, we're going to return a 405. And if this ever happens, we're just going to say error has occurred for us to log it. All right, and that is pretty much entirely how you implement JSON Web Tokens. To briefly go over it, do we ever check for ID input? I guess we didn't need these. Sometimes I use these in my projects. This might be a useful thing to have and export. So maybe export const to ever, if you want to create things to check if a user's already authenticated or not, or get their user object, you can do that. But for the most part, we just need that. And let's go to our wonders and get that working as well. Okay, so for the most part, create a JWT check. So const JWT check is equal to express JSON Web Token. And with that, we need to just provide it the exact same API key we had earlier. Imagine that this is in a .env, by the way, because it's not secure to have this in plain text. And then I guess this is where you would probably need this. So we can actually const create token and check ID. We can take that straight from, is that right? That would be instead users. Okay, there you go. Just making sure that looks right. Actually, we shouldn't be creating tokens here. Only check ID or check input. All right, and with that, we have that there. So now that we have check ID input, check ID exists, we can use this straight up with our different resources. So let's go ahead and do a I think what we can do is we can literally just do a JWT check, and we can add that to all of these. And essentially the way it works is if it sees a what's called a callback function in between these two, it will apply it automatically. So we can add that to any route that we want to secure, like so. And now all of these will run the JWT check function, which will use express JWT and go through our entire process. And let me just check if that is right. Yep, it is. Awesome. Okay, so crossing my fingers that this works. I'm unsure if it will work because once again, we haven't actually tested this yet. So I'm gonna cross my fingers, npm run start, knock on wood. Dang it, it didn't work. What broke? Can't find modules, models. It's theirs right here then. Oh no, right here. Why can't I find models? Did I not export? I did export. If anyone has any clue to why this is not working, feel free to make edits and changes. I don't know why I can't find models because I can find it. It's a directory. If any of y'all have any ideas why this is not working, feel free to edit it. Oh, I realize why. I realized that in models, with the current way that we're working with common.js, we actually have to have an index.js here to control everything. I completely forgot about that. So we need to do a called const fs is equal to require fs. Then with that, we can do an fs read dir sync, give it a dir name dot filter. Let me pass it. Trying to get this in on time. File, and with this, you can return a file dot index of dot does not equal to 0. So if it's there, and if a file does not equal to index.js, so it's not including itself. And then with that, we're able to do a for each file. And we're able to do a const model is equal to sequelize.import path.join. We're going to join the dir name and the file together. That we can do a db of model.name is equal to model. And once we have that, we can do object.keys. So we get all the keys for the DB or all the tables. Do a for each. And then from this, we take in the model name. And do if sure. Looks right to me. I trust that Copilot knows what it's doing. And then we do db.sequelize is equal to sequelize, which we need to import as well. db.capital sequelize is that, and then module.exports is the db. I'm going to ignore that method. And then we need to const sequelize is equal to acquire sequelize, and lowercase sequelize is going to be new sequelize, and it's going to take in database, username, password. Is that right? Yeah. There we go. And saving all of that. I don't know if anyone made any changes on here, but this should work now. Oh, I forgot to define path. So also have to do that. Const path is equal to acquire path. Sequelize.import is not a function. Huh? I'm not sure why this isn't working. This is what I get for not working with the most latest of standards. It's a little bit on me, but this should be working. Because sequelize.import should be a function. Let me check. Googling it right now. Not a function. Okay, so it's saying this in Stack Overflow. Old Faithful. Hopefully this works. Okay. It's going to the database. Let's see our database if it's working. We are at the top of the hour. Let's see if this works real quick though. Okay, so y'all aren't able to see it, but I'm opening up Postman. And I'm gonna see if I can hit the, what's it called? Let's see if I can hit the endpoint. So our endpoint that we have is gonna be users. Sorry if anyone has a stream after me. We're gonna do a register and see if that works. And that will be, if that works, we'll call it GG. So we're gonna do register. Okay, and if it's register, we need to provide it a, what's it called? We need to provide it, it's in the body, okay. So in body, we need to provide it a name. I'm gonna name it Ryan number 3. Then it needs a username. I give it my username that I use for everything, and password. Sorry about that. Password is gonna be, name it password 123. Oh, not patched. It's gonna be a post. Oh, /users. Whoops. So close, but it's not working here, but we are at the top of the hour. I'm sorry, y'all, that we weren't able to complete the entire stream. but trust me that we were very, very close to getting it to work. And for the most part, we have implemented JSON Web Tokens. But if you enjoyed the stream as much as I have, please feel free to go to other Global Hack Week streams or go to other Global Hack Weeks and catch me there. But it's been a lot of fun, y'all. Thanks for showing up. And yeah, happy hacking. All right, see y'all. Thanks for joining me.